Hi everyone, I am your virtual tutor, and today I will teach you all oh, about the arithmetic series. But first, how do we define an arithmetic series? An arithmetic series is defined as a function whose domain is a finite or infinite number of terms. It has the so-called the common difference. But now, how do we define a common difference? It is as simple as this. For example, the numbers 1, 2, 3, 4, and 5. The common difference is the difference between the consecutive terms. For example, the terms 1 and 2. The common difference is 2 minus 1, which will be equal to 1. Now, if we continue this to 2, 3, 4, and 5, we will get 3 minus 2, 4 minus 3, and 5 minus 4 respectively, which will give a result of 1, which will be the so-called common difference. Therefore, 1, 2, 3, 4, and 5 are considered an arithmetic series. Now, what if we are asked to solve this kind of problem? Find the seventh term of 1, 3, 5, 7, and so on. How to find the seventh term? And how to find the nth term of an arithmetic series? So to find the nth term, we should analyze this equation. Let's say the first term is a sub 1. Then, the second term will be the first term plus the common difference, which will be equal to d. Therefore, the second term will be a sub 1 plus d. The third term will be a sub 1 plus twice the common difference, which is d. And the fourth term will be a sub 1 plus 3d. Therefore, by continuing this pattern, we can now get the a sub n as a sub 1, or the first term, plus the product of n minus 1 times d, where a sub n is the nth term, a sub 1 as the first term, n as the number of terms, and d as the common difference. Let's go back to this problem. Find the seventh term of 1, 3, 5, 7, and so on. By going back to the formula we got earlier, we got a sub n is equal to a sub 1 plus n minus 1 times d. Applying that to this problem, we will get a sub 7 equals a sub 1 plus 7 minus 1 times d. A sub 7 will be equal to the first term, which is 1, plus 7 minus 1, which is equal to 6, multiplied to the common difference, which is equal to 3 minus 1, or 5 minus 3, or 7 minus 5, which is equal to 2. Solving this, we will get 1 plus 12, which is equal to 13. Proving this using the long method, we will get 1 as the first term, 3 as the second term, 5 as the third term, 7 as the fourth term, 9 as the fifth term as a result of 7 plus 2, which is the common difference, 9 plus 2, which is 11 as the sixth term, and 11 plus 2, which is 13 as the seventh term. By using this long method, we can say that using the formula takes less time than solving it manually. Therefore, using the formula is more advisable when solving for the nth term in an arithmetic series. But now, how do we find the sum of a finite arithmetic series? It goes like this. Let us say that S sub n is the sum of the terms. We can say that S sub n is equal to the first term plus the first term plus the common difference plus the first term plus twice the common difference and up to a sub n. We can also say that S sub n is equal to the last term or the nth term plus the nth term minus the common difference plus the nth term minus twice the common difference up to a sub 1 or the first term. Adding this vertically, we will get 2s sub n equals a sub 1 plus a sub n plus a sub 1 plus a sub n plus a sub 1 plus a sub n. Therefore, s sub n is equal to n multiplied to a sub 1 plus a sub n all over 2, where n is the number of terms. Now, we can find the sum of a finite arithmetic series using this formula. Again, to find the sum of finite arithmetic series, we need to use s sub n is equal to n multiplied to a sub 1 plus a sub n all over 2, where n is the number of terms. Let's have some examples. Now, let us solve this problem. Find the sum of 5, 9, 13, up to 101. How to solve this problem? Of course, we will use the formula we got earlier, which is S sub n is equal to n multiplied to a sub 1 plus a sub n all over 2. Applying that to this problem, we will get S sub n is equal to n multiplied to the first term 5 plus the last term 101 all over 2, which is equal to n multiplied to 106 all over 2, which is equal to 53n. But how do we find n? We need to use this equation. D sub n plus a sub 0, which is equal to a sub n. This formula is called the recursive formula, where d is the common difference and a sub 0 is the term before the first term. So, as the common difference, which is equal to 4, and a sub 0 as 1. Therefore, 4n plus 1 is equal to 101. Solving this, we will get n as 25. Substituting that to 53n, we will get 53 times 25, which is equal to 1325. Therefore, 5 plus 9 plus 13 up to 101 is equal to 1,325. Therefore, we got the sum of a finite arithmetic series. Now, let's try another example. Find the summation of 2n plus 1 where n is equal to 1 up to 20. To get the answer, we must use again the formula S sub n is equal to n multiplied to a sub 1 plus a sub n all over 2. But first, we need to get the first term as well as the last term by simply substituting the minimum and the maximum value. Therefore, a sub 1 is equal to 2 times 1 plus 1, which is equal to 3, and a sub 20 is equal to 2 multiplied to 20 plus 1, which is equal to 41. We can now use the formula given. S sub n is equal to n multiplied to a sub 1 plus a sub n all over 2. N is the number of terms, which is 20, multiplied to the first term 3 plus the last term 41 all over 2, which will give you the answer 440. Therefore, the summation of 2n plus 1, where n is equal to 1 up to 20, is 440. We are done with finding the sum of a finite arithmetic series. But how to find the sum of an arithmetic series which is infinite? It goes like this. A while ago, we said that to find the sum of a finite arithmetic series, we need to use the formula S sub n is equal to n over 2 multiplied to a sub 1 plus a sub n. And we also said that a sub n is also equal to a sub 1 plus n minus 1 multiplied to d. Substituting that, we will get S sub n is equal to n over 2 multiplied to a sub 1 plus a sub 1 plus n minus 1 multiplied to d. Therefore, simplifying that equation, we will get S sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to d, where n is the number of terms, a sub 1 as the first term, and d as the common difference. Now, let us try to use this equation. Let us solve this problem. Find the sum of 4 plus 11 plus 18 up to a sub 16. Since this is an infinite arithmetic series, we will use the equation S sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to d. Substituting the values, we will get S sub n is equal to 16 over 2 multiplied to 2 times the first term 4 plus 16 minus 1 multiplied to difference 7. Simplifying, we will get 8 multiplied to 8 plus 15 times 7, which is equal to 8 times 8 plus 105, which is equal to 904. Therefore, the sum of 4 plus 11 plus 18 plus up to a sub 16 is equal to 904. Therefore, the equation or the formula S sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 times d, which we used in this problem, is applicable for infinite arithmetic series. Let's have another problem. 1 plus 3 plus 5 plus 7 up to 2n minus 1 is equal to 961. Find n. This is an example of an infinite arithmetic series. Therefore, we need to use the formula s sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to d. Substituting the values, we will get s sub n is equal to n over 2 multiplied to 2 times the first term 1 plus n minus 1 multiplied to 2. Since the sum is given, we will substitute it to s sub n. 961 is equal to n over 2 times 2 plus 2n minus 2. 961 is equal to n squared. Getting the square roots of both sides, we will get n is equal to 31. Therefore, there are 31 terms in the arithmetic series, and the last term will be 31 times 2 minus 1, which is equal to 61. Therefore, if you add 1 plus 3 plus 5 plus 7 up to 61, we will get a sum of 961. After discussing arithmetic series, we have 4 things to remember. Number 1, arithmetic series is defined as a function whose domain is a finite or infinite number of terms. It has a common difference. Next, to find the nth term, we can use the equation a sub n is equal to a sub 1 plus n minus 1 multiplied to d, where a sub n is the nth term, a sub 1 as the first term, n as the number of terms, and d as the common difference. Next, to find the sum of a finite arithmetic series, we need to use the equation s sub n is equal to n times a sub 1 plus a sub n all over 2, where s sub n is the sum, n is the number of terms, a sub 1 as the first term, and a sub n as the last term. Lastly, to find the sum of infinite arithmetic series, we need to use the equation s sub n is equal to n over 2 multiplied to 2a sub 1 plus n minus 1 multiplied to d. Have you learned something, guys? Thank you for watching. And again, I am your virtual tutor teaching you all about arithmetic series. Have a great day, guys!